Hi everyone, in this video I want to talk about finding the distance between 2 points on a graph. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. If you had to perform a dance move in front of the whole world, which would you pick? Alright, so distance. This would fall under coordinate geometry. Um, Coordinate geometry is a big umbrella that basically is just anything related to shapes, or in this case lines, on an actual coordinate graph. We'll just call that coordinate geometry. Uh, Sometimes students will learn this concept in algebra, but it is on the ACT. Sometimes the types of problems that involve this concept are a little bit harder than these two, meaning, like, let's say you had to classify a shape uh, to decide whether or not it's a parallelogram, say. You could use the distance formula to find the length of the sides of a shape. But I think it's important to practice these two problems, one given just the coordinate pairs, and then the other giving you the visual. So distance between 2 points. In order to do this, we must need to know the formula. So d equals square root, and then it goes x2 or x sub 2 subscript 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The whole thing has the square root over it. So right here you could call this x1 y, x2 y2. A lot of people just say x1 y1. Should technically be x sub 1. But anyway, so you are going to get a large square root after this. Another note about memorizing the distance formula, for some reason I always remember that it goes minus plus minus, and that is consistent with the equation for a circle as well. So minus plus minus is just that really quick thing that jumps in my head when I think distance. So here we go. X2 is 2 minus -8. We have to be careful that we do the minus negative properly. Add, and then 1 minus -7 squared. So right here, when you square something in parentheses, that part will always become positive. And that's something I want to point out in this next one, where perhaps you would have a negative in the parentheses and then you'd have to square it. Right here, though, we just have to make sure we remember that minus a negative would be a positive. So we get 10 squared plus, and then this is 8 squared. So if you look in the fractions, it says the answer should be exact and not rounded. So we have 100 plus 64. That is the square root of 164. And if you remember back to Algebra 1, the square root of 164, you could do two different ways. I'm going to do it, you could simplify it, that is, two different ways. The first way is you take 164 and break it into all of its prime factors. So it's even, so I'm going to take a 2 out. What's left over? 81. Nope, 82. And then 82, let's take a 2 out of that. We get 2, and 41 is prime. So if it's the square root of 2 times 2 times 41, I have a double of the 2's there, and we have 2 root 41 as the answer. Remember, when you see a double, only 1 comes out because you're square rooting that. The faster way to do this is take the largest perfect square that can come out of 164, which might require the use of a calculator. You would sit and try a bunch of them, like 1, 4, 9, 16, 25, and so on. And then we would have 4 being the largest, 21 is left over, and then there it is again, the 2 root 21. So either way, oh, no, not 21, we have 41. There it is again, the 2 root 41 is that exact answer. It's not rounded, there's no decimal. In the second problem, I made the directions a little different, where you'd have to use a decimal to the nearest tenth. So find the distance between this pair of points. Well, we have -2 and -2, and then 2, 2. So sometimes you have to use a diagram to extract the points from it. In this case, they give you the little circles to note that, but you would just notice where does it cross those corners. And that would be an actual point that you could use for the distance formula. So in this case, D equals, same formula. What I want to do here is call this point x1 and y1, this x2, y2. Because what happens here, nope, I'm going to reverse that. The reason why is if I call this the x2, -2 minus 2, and square it, and then I do, once again, -2 minus 2, and square it, we end up getting a negative in the parentheses, and I wanted to show you that. So if you happen to call the top one the first point, the bottom one the second point, you would end up getting -4 squared plus -4 squared. And we have to use parentheses around that -4. Otherwise, we would get a -16 underneath the root symbol. So this is 16 plus 16. A lot of students would call that, oh, the answer is square root of -32. But it's actually +32. So we have to be careful with that. If we're inserting numbers in for variables, we will always have them in parentheses. Now, square root of 32, we could use the same concept right here to simplify it, but it says nearest tenth. So the square root of 32 rounds to 5, is about 5.7. Okay, so let's move on to some practice. Here are 2 problems that mirror exactly what we did, same directions. So take a second, pause the video if you'd like to work on them without seeing the answers. There are the answers. The first is exact, the second one is rounded. Okay, quote, great one. The key to success is failure, Michael Jordan. Something I think about with Michael Jordan is that he didn't make his high school team, in high school basketball team, first time around. There's that growth mindset. Work on something that you want to achieve over time. So I hope this video benefited you in some way. If you want to put your answer to the fun question about the data move, comments, that would be great. And if you want to keep up with videos, I encourage you to click subscribe. Have a great day.